Our next presentation is on managing complexity in semantic data mapping, a test-driven development approach. And for that, I'll give the floor to Maria Keet, who is R&D Manager and Senior Semantic Engineer at MeaningFi in Luxembourg.
Yeah, thank you. Good afternoon, everyone. So my name is Maria Keet. This work that I'm presenting here is in collaboration, obviously, with my colleagues at MeaningFi, and the ideation and the implementation of it actually also goes to the credit also for my colleagues, Eugenio Costecchi, Songo Niulas, Rashif Rahman, and Jana Ahmad. I wanted to have those ones mentioned as well, to give due credit. So what we'll be talking about first, the problems that we'll be addressing here in the semantic data mapping. We have a new methodology and tool to handle the complex mappings, basically, that we're looking at. And then we look at how does it solve the problem, and we'll finalize at some conclusions there. So oops, there. There's this version. Okay. The basic story is that we started with a practical problem from public procurement data. A lot of it is stored in XML files, and messy is here in snake quote because it's not a complete mess, but there are loads of variations of the different files that we actually have to deal with. And that data from the 20th century technology, we want to move into our 21st century technology, into clean knowledge graph. Not that we have imprecise, semi-structured data, we dump it into RDF, and then we're going to clean it. No, what we want to do is actually a good quality conversion, that what comes out of the conversion in a knowledge graph is straight away a high-level knowledge graph. Why is it? So for that we're going to look at on how we're going to solve this. For the practical examples and a use case motivation, they are concretely from the Tenders Electronic Daily, the specific data from that XML schema, and that has to be mapped into the knowledge graph that is actually guided from the top down by the eProcurement ontology that is linked to it. So this arrow over there, that doesn't work. No, I was thinking it can point, but there's no pointer working here. Okay, so that little arrow, the black arrow there, looks like it's easy. What we are going to look at is how that actually is going to work, and that's not as easy as the simple arrow. Initially, you may think, well, look, it is easy. We have an XML, and for the XML, we have an XSD schema. If we have all of those XML files adhering to the XSD schema, we have a nice mapping there. We just map the XSD schema to the EPO ontology, and then automatically our data loads into our knowledge graph. At least that is the nice idea that you initially may think that would work. That's what we were hoping for as well initially. However, it's not that simple. What do we have? We don't have one mapping, as you see there in one nice little line. There were over 1,000 concepts that actually had to be mapped from the different XML schemas and the XML files into the knowledge graph. You can't do that just with one line drawing over there. There were 40+ different document types. We had data into 2 different core formats, and they are the standard forms and e-forms. Standard forms, you had 5 schema versions. The e-forms, they have 13 different versions, and it actually continues changing to this day. The ontology itself has been evolving as well. Started when we came on board, started with version 3. Currently, we are in version 5. So that means you have all of those evolving data specifications that has to map into an evolving ontology, an evolving knowledge graph, whilst maintaining everything, all the mappings and the conversions from the original data into the knowledge graph, that the correctness is being maintained. Because it has to be legally correct. We cannot afford any kind of mistakes over there. So errors can creep in if this is not extremely carefully managed. And manual validation of all of those different variations is painful to do if you have to do that manually. So we don't want to do that. What we want is to go from that sort of chaos with all of those different versions to a neatly structured methodology and an approach that we can reproduce can use, and that it actually proceeds correctly from there. So we have a new methodology and tool for that. The key requirements that we are looking at, okay, we want to solve that for this case, but also for other cases when other people have XML data and they need quality conversions. So you want to have one place to manage the complexity without drowning in specific tooling. Collaborations between experts and engineers so that the domain experts also can have confidence in this conversion that it actually has been done correctly. Those mappings, therefore, also must be testable, explainable, and maintainable because of all of those changes. Methodological approach to those mappings and how to do the mapping specifically. And then we want to have one platform to support that full mapping life cycle. And if you have one cycle of mapping done, you can go back and revisit it or revise it if you want to or if need to be. So here is a summary overview of that methodological approach. First component out at the top in the preparation is really looking at studying the relevant data, what sample data, what specific data do you want to transfer, what is exemplary of that. The first layer then, which you see conceptual mapping, is where we map what needs to be mapped from the source to the target. We'll see details in a little bit. And that doesn't say yet how, so that also if technology changes later on, we would be able to reuse our conceptual mapping and just have a different implementation. Or if somebody wants a different technology, fine, you do your technical mapping in a different place. The technical mapping is really where we make those conceptual mappings machine readable and usable, and that we actually can do the conversion from the XML data into the RDF. Next layer is validation with the SPARQL validation and SHACL validation, SHACL with respect to the data. And if all goes well, then you want to have all of this data that has been generated put into one mapping package for documentation and posterity for that. So we have, for that methodological approach, we have developed a specific tool, and it's called Mapping Workbench, which is an IDE for building the knowledge graphs from the legacy data, and specifically with the semantic precision that is required. We have our methodology there, test-driven validation with the automatically generated SPARQL and checks and the SHACL shapes. Collaborative workflow where the business developers, experts are involved as well. And we have multiple format support. Currently, we've been focusing on RML and RML Mapper. There is planning, and we're working on YARM, on SPARQL Anything, and other ones, depending on the interest from the community there. So how does it look like specifically in our instantiation from the methodology to do this mapping? So mentioned first, we do the conceptual mapping. That is basically looking at the XPath queries that we need to execute over the XML. That maps then to a SPARQL property path and a SPARQL class path. And if you look at here, I had hoped that this one would work. There, yeah. The conceptual mapping there is then the output. That is a specific document, and even though that we have our generic methodology, what we're using here with the conceptual mapping is not going to be just shelved. It is going to be reused in the validation component, not only at the conceptual layer and then for the technical layer. For the technical mappings, as mentioned, we're using the RML rules. Over there in that practical implementation, the technical implementation, we also handle the non-isomorphic transformations. Also, in some cases, one thing is a property or an attribute in XML that may end up as a class because that is how it's modeled in EPO. Those kind of non-isomorphic transformations are handled there as well. And then we have our validation, as mentioned, with the SHACL and the SPARQL, and we have a report and outcomes, then specifically the semantic knowledge graph with the high precision that we needed to have them. So how does that look like? You may still, even now, think in this presentation, look, we just create the mapping rules over there, and that's the only thing that deals with, that we are dealing with. It is actually not just the mapping rules. That is basically what this tool and the methodology look like. It works on how to do that systematically. Once we have that mapping rules, it's given to the transformation engine. It's a transformation engine that does the translation from the XML into the RDF. So what do we map? We have elements in the source files, and we see on the left-hand side the terminology that, for instance, a procurement expert is familiar with. They may, for instance, know place, performance, city, that they are familiar with in their terminology. The data engineer is trying to find that one in the XML files and specifying what is the XPath query to get that information out of it. That is still only that mapping at the source, but that's not the conceptual mapping that we're talking about. Our tool helps with that. Basically, you can load it and you just can point and click instead of manually having to write that in, say, like in a spreadsheet or something like that. So there are some auto-completions there as well, and you can specify that and store that and point to it in a later date. Then we're looking at, in the target, to what do we map? And then we're looking at, for instance, in this case, the city, in the context of place, performance, city, with respect to the semantics that was implicit in the XML file, we have to look at which city or which uses of the city in the ontology that one actually maps to. Because there are cities also used elsewhere, but we need to map it to the right city. So that is basically an ontology snippet that is specified as a class path and a SPARQL property path. Once we have done that, we have our source and we have our target. That is our conceptual mapping. We then map it to, or implement it in what we call the technical mappings, and that is our RML file. Because the conceptual mappings, what needs to be mapped is useful for the humans, but our machines need to implement it. So we see here this snippet as an example of one of those technical mappings. So each of those conceptual mappings need to be implemented in this way, using the RML currently. Once we have that, you can say, okay, we are done. Actually, what we want to know is, in the first instance, did we make this translation from conceptual mapping correctly into the technical mapping? Plus, did we want to look at the quality of the transformed data from the sample data that has been selected up front in the first stage? So we have three aspects of the validation for that, at least at the current stage. Obviously, you can imagine perhaps more validations, but these one are the first core ones. We have an XPaths coverage report that basically looks at how much of the input data is covered by the mapping rules. Because at some point, we also want to make sure that we have covered everything from the XML that we wanted to map. Not that we forget something that actually is supposed to end up in our RDF graph, that we haven't overlooked it. So you want to be sure about that. And we will also check from how many mapping rules are actually testable. So this is the first component. So I have a coverage report. You can go into more details. This is just the dashboard up front. There are more details afterwards in the tool itself. There is this coverage for the SPARQL queries, basically looking at, did we implement each rule correctly? So the SPARQL ask queries to double check, is everything there in the graph that we need to have in our graph? Third one is looking at, does the transformed data conform to the design data shapes? And they are SHACL shapes automatically generated from those conceptual mappings. Wrapping up, because also sort of my time is close up. If we're looking at it from the perspective of contribution to the semantic interoperability and knowledge graph construction, we established a structured methodology for high-quality XML to RDF conversions, test-driven knowledge engineering with the notion of conceptual mappings and an implementation. We introduced a mapping IDE to systematize and streamline the semantic data integration. Overall, it gives a scalable scalable foundation that is also applicable to other domains, reinforcing the role of semantics actually in enabling AI-ready and machine-readable government data. Benefits overall, it helps managing the complexity because of a consistent and test-driven methodology. You can scale it up to thousands of data points. Bridging expertise by working collaboratively, even though that I didn't show it as much in the 15 minutes available, but it is possible in the tooling and the methodology as well. Speeds up the mapping process, and thanks to the testing, we can find gaps before running it at runtime usage, getting our validation reports, and if there are any issues, we can resolve them before it's being thrown to the public for usage. So we get at the end a better quality knowledge graph out of it as well. So that's it. That was all. Thank you very much. I'm happy to answer questions.
Great, thanks very much. So let me check first if we have any questions here in the room. Yes, one here.
Hello, good afternoon. It's a very high-level comment. I see that we try to do the mapping to ontologies from XML document. I see that we are experimenting with graph RAG or light RAG. Will not be a perfect world where at source our documents are knowledge graphs. I mean, if you look at the evolution of the web pages nowadays can be knowledge graphs, meaning we see them as HTML pages, but basically they are ready, you can publish them as machine actionable documents. So maybe there's a reflection on our tools, our edition tools, that we can use instead of trying all these nice, fancy new technologies, embedding LLMs. At the source, we provide knowledge graphs to the LLMs. That was my comment.
Yes, sure. The thing, however, in this case is that there are quite a number of organizations that are still stuck, or they still have or still use XML for a variety of reasons. Some people feel stuck, some people are happy with it, and they want to have both ways, whichever. But yes, if we can move to already straight away starting with the knowledge graphs or the ontology annotations, for instance, of the eForms, you could think of that one because it also supports eForms, to actually annotate the eForms already with terms from the ontology, and then you already help this notion of the conversion or the direct linking to the ontology and the annotation of it. Yes, that is a different scenario. I would support that, definitely. You have me on your side. The one thing here for this one is there are so many organizations who still have this XML, and they still want to have the benefits of the semantic technologies. So therefore, we need to have this, this conversion pipeline. The other thing is also that it's not only the XML people, but there's one slide that I removed because of time, is that you're also looking at a JSON and a CSV. Yeah, exactly. Specifically for the people from the IoT domain, the digital twins domain, all of that direction, they have a lot of CSV files. They also need to do this mapping, so that we're looking at extensions for that, because that is the reality still that people have this data. They don't want to throw out that data upfront.
So we just have time for one more question, and I'm going to take one from an online viewer. So the question is, does the proposal take into account SSD XML schema as input? If not, what can you suggest if someone comes with XSD to have RDF?
Sorry, I was wondering, sorry. Can you repeat it? Because they were signaling that I...
So does the proposal take into account XSD as input? If not, what can you suggest if someone comes with XSD to have RDF?
It can take, currently the implementation itself can take the XSD in the context of the eForms, because the eForms has the XML also with the XSD coming, so that comes as a package, and it comes also as an SDK that can be loaded straight away. So yes, that already works. If you're asking me currently any generic arbitrary XSD, that would be in an extension that we're currently scoping, that you have that combination for any arbitrary case, yeah.
Okay, thanks. I know there were more questions in the room, but you can find Maria probably in the coffee break. Another round of applause for Maria.